Hi everybody, I'm talking to John Bywater today. John is building application mainly in the Python world, mainly in Python. Has been doing event sourcing for what, 10 years, something like that, and
Something like that.
yeah, and has an event sourcing library in Python, of course, and recently also built a client library for Event Store, which also plugs in into your library anyway. So is that kind of accurate what you're doing? What kind of you know building application? What type of application are you building?
Oh, well, I've been doing a whole series of projects for different companies over the years, and the Python library came out of that. I wanted to take what I'd learned in one place forwards and build up one open source piece of code rather than a series of smaller efforts in people's proprietary repositories,
Mhm.
for my own benefit, really, so I wouldn't have to do the same thing over and over again. The first time I did it, I had to ask for 2 weeks at the beginning of the project to just make something that we could use, and they were generous in letting me do that, and it really helped. So I just thought it would be good to to take forward learning from one job to another, and it just came out of that. And then after a while, other people found it useful, um, and then I started trying to make it work with different databases. The first one was Cassandra,
Yeah.
which had some, good qualities, scalability, but then other ones, such as sequencing by the timestamp UUID, which has a jitter thing at the end. So, okay, and there's no total ordering of the events across all of the partitions. So it was slightly, it worked what we were doing, but that was the first thing. So then I tried to over the years and made it work with different databases. And Event Store obviously is a one of the leading specialist event store database.
Yeah.
So at some point I tried to make a client for that, and the new version that we've put out, the stable version, is just the result of a few years work, really, trying to make that happen.
Yeah. There's quite a journey or that's happening there, but there will be some webinar soonish, given the moment of this recording, that will kind of go into detail. Do you remember how you came across event sourcing and this kind of way of building systems?
Yes, I came across it when I started looking for events. So I've been doing the Python event sourcing in Python for perhaps 10 years. But before that, I was doing domain modeling going
Mhm.
back to 2002, 2003. Um, Previous to that, I was doing the kind of tiered architecture. And I was always interested in trying to find a kind of domain modeling, have the business logic in the middle of the database underneath and the presentation there above. Um, and then Martin Fowler's Patterns of Enterprise Application Architecture came out, followed by Eric Evans's Domain-Driven Design. And at that point, I was consulting, and I was trying to get to having something that followed those patterns, which was general, that I could just use as an abstracted layer over encapsulating the common aspects of doing those things over and over again. But every project, I had to keep returning to this thing to try to fix it, to cover some extra cases that it just didn't work for. Um, and the more it changed, the harder it got to change it. And it just became an exhausting thing to do. And the thing that really killed it was firstly bitemporal. The reason I had to give up, because I was really dying trying to make it. I was trying to get to some satisfaction with it. And it was bitemporal association object, where you have a two domain objects which are bitemporal, and you've got an association between them, and you're trying to do that with concrete tables by reflecting from the domain model into the database.
Yeah.
It just got to the point where I was like, I really don't know what's going on here anymore. And I was trying to just trying to like get it done, so I wouldn't have to keep returning. And it started frustrating me. And at some point, it was just too exhausting, and it was just too hard to think about, abstracting from those kind of things. I didn't know what I was doing really. So I backed off and left it for maybe a year. And I was disappointed because I was doing my best to follow the advice, from the best people, and I thought I'd paid attention to it as well as I could, and I just felt like maybe it's just me. I'm just no good at doing this software stuff. And then I just fell back onto more raw feelings by asking myself, what's actually happening here? Like, why can't I see what's going on here? What's actually happening? By asking that question, what's happening, I hit on this notion of events. And a short while later, I started like Googling for events, and then it all came up, event sourcing, that the thing to do is to work with things that don't change, because you're working on solid ground. Then you're building on something that's solid. Solids don't change. And if you're working with objects that do change, then it's fluids that change, and you don't want to build your castles on sand. So that was the breakthrough for me. And then I in parallel to all of that, I'd been for many years interested in various branches of philosophy, actually.
Yeah.
And I'd, on my travels, I used to go to different philosophy conferences. And on my travels, I'd come across some people who specialized in this obscure guy called Whitehead. And I used to talk to them and have no idea like why they were bothering this stuff. And I had no clue. I mean, I had a vague impression of what he was talking about, something to do with the world being built up from events, and I had no idea. Like, you can jump into all sorts of schemes and like explanations. There's thousands of them, and you have to have a good reason for, because otherwise you might just end up drinking the Kool-Aid on something that's completely mistaken and just go a bit crazy. So I had no reason for going into Whitehead's scheme, until I realized that events are actually quite an important thing. And then I realized what he was talking about and why his scheme was actually interesting. So yeah, so that helped answer the question, like, is event sourcing general? Because when should you do it? With the common answer at the time being, you shouldn't always do event sourcing. It's only applicable in certain cases. Yeah. Which I believed, but I was then looking for when I shouldn't do this. Like, if I'm doing different jobs for people, if I encounter some, a client with a domain, how will I know that this isn't the place to do event sourcing? Like, what is it about? How can I? What's going to tell me? What should I look out for to know when it is a place? And I thought about it for quite a while, really, and came up with the idea that there aren't any domains that aren't built up from events. So it's always at least applicable. You can always grasp a domain by its events, which is basically what Whitehead was saying. The world is built up from things that happen, and they fall into the past as facts. And that's what event sourcing is. So that's how I got into it, by actually failing to do the previous non-event sourced approach to some degree of satisfaction. I mean, it works. I think the interesting thing is, from an event-oriented understanding of things, you can look back at the non-event sourced domain models and see that they too are built up from things that are happening. It's just that the decisions aren't being made explicit as event objects, which actually is okay. It's okay to do that sometimes. It's just that then you lose an explicit record of what's happened, which makes it challenging to propagate the state of your application across the network, and can make it challenging to maintain the integrity of the recorded state when you've got concurrent operations writing to a bunch of tables that have been created through a kind of concrete reflection from the domain model.
Yeah, what you said about that a few years ago, general advice was apply event sourcing where it matters. For my part, I believe that back then it was also because the pattern and there is a learning curve to it, because you need to model differently, you need to think about your system differently as well, and build your system differently, so that there is this learning curve, and that the body of knowledge was not back then, let's say 10-ish years ago, wasn't really written down or generally available in a consumable way. So that's my belief why this advice was given back then, right? Hopefully now, and even more in the future, I hope that the body of knowledge will be spread enough that there is enough ground, common understanding of certain topics around that, and certain aspect, the modeling aspect, and how to code. That advice is maybe not really relevant, or less relevant than yeah, let's say 10 years ago.
Yeah, that's very true. The answer to the question when you shouldn't do event sourcing really turns out to be that you shouldn't do it when you really need to succeed, and the team doesn't know how to do it, isn't experiencing it, because you can fail to do it because it isn't just a simple thing. Yeah. So working through all the consequences of an event-oriented approach involves a little journey really into there's a number of things that you have to kind of do to make it work well. There's a number of things that you have to take on a certain a certain amount of considerations you have to be aware of and actually make work well. So that's why it's not just a simple thing, isn't it? And it's still true that it's if you really need to make it work and you don't know what you're doing, then with anything really, it might not be a good idea to there was an old thing in software about never use a new tool in a new project, especially if you need to succeed.
That's true for anything. I mean, if I look back at my own career, what I did at the beginning, even with the knowledge I had back then of relational and so on, I would do it completely differently today, because just the experience or the it's probably a question of experience there, and which kind of brings me to the fact that we kind of discussed earlier about that, is that the library you built kind of, I think is something that can help people bootstrap their knowledge as well, because there's this aspect of people learning. I mean, especially developers, let's say, where they need to see code to understand, or I mean, the understanding come with code for that part.
Yeah, that's right. I mean, it's open source software, and there's the four freedoms, obviously, of free software. One of which is just to read and learn, and we learn. We can learn effectively through kind of self-invention, through figuring it out ourselves. But one way we learn is by learning from other people, how they've worked it out. And writing helps to communicate things across space and time. And software is a form of knowledge in that way that helps people to learn how you can do things. So the first thing that an open source, a set of like some open source code for anything is that you can actually see how somebody's been doing something, and yeah, and then the particular package, the particular event sourcing package, the particular Python package, which is called event sourcing, has different layers. So there's the core. So in the documentation for it, I do make this quite clear. There's different layers, and the core thing is the persistence mechanism. So that's having a persistence mechanism. Event sourcing is described as a persistence mechanism for domain-driven design in one formulation. And in Eric Evans's book, he describes a cohesive mechanism that you can extract and factor out a cohesive mechanisms if there's something that you can recognize could be usefully separated. And so you can apply that pattern, the cohesive mechanism pattern, to the persistence mechanism for domain-driven design. And you end up with a persistence layer for event sourcing that allows events to be, the methods are simply append events, select events for a sequence, and then sort of select the notifications out from the total ordered events across all aggregates. And then there might be some other things that are useful too, but those are the core things. And that's what you want to kind of call from any domain model, really. That so the other layers above the persistence layer are so you can make an abstraction of those things and an interface really that you can implement in different ways. You might want to have some compression in there, you might want to have some encryption, you might want to serialize in different ways, and then you might want to record your serialized things in different databases, event store, or Postgres, or memory.
Nothing else.
There's a range of possibilities there which have different qualities too. But then once you can record events in sequences, you can get them all out in a totally ordered sequence. Then there's the question of how do you reconstruct an aggregate from events? Also, how do you trigger new events from an aggregate by calling its methods? And how do you do that in a way that allows you to collect all the events together that result from one operation, so that you can then atomically record all these events, so you don't have a kind of halfway inconsistent recorded state because you're saving them one by one. So there's the, and then how do you express your aggregate in a way that gets out all of the repetition? All the repetition that means you're doing event sourcing is additional complexity to the complexity you already have to express your business concerns in your domain model. So it took a few years really, and some great suggestions from users. I mean, they weren't mine, but just gradually teasing out the repetition and factoring it into, just putting it in the background, so that, yeah, so we've come up with a very concise declarative syntax for event-sourced aggregates, which in the first instance just demonstrates how you can do this. But it turns out that all the effort that's gone into getting to something that looks nice turns out to be a very useful, workable way of doing it. Obviously, there's lots of other ways of doing it too, some of which are explained in the documentation of the library. Yeah. And then the application layer, it just brings together the domain model and the persistence layer, and those two things need to be brought together to make a, so again, we're moving one step further away from the core mechanism, but then you have three different modules in the library, and then there's this additional thing which is even further away, which serves as an example for learning, but also can be used in production. Is the system, the event processing bit, goes out a little bit beyond event sourcing, but the fact that you have a total order of all of the events in your application or your bounded context or whatever you want to think about it, and means that you can do event processing. You've got a position in there, and you can do event processing, avoiding there's the dual writing problem. But you can do events processing in a way that's reliable, and just gesturing towards. But at that point, you're getting involved in more operational concerns, and the possibilities really explode. So the system module in the library is really more than anything else indicative and for demonstration purposes rather than really the final answer to anything.
That's I think you said two things which are interesting, at least for me, and I guess for others as well, because there's a lot of arguments. So for instance, EventStoreDB has total ordering, and we kind of call it global ordering, but I'm kind of explaining it a bit differently. Is one of the qualities I want from the storage is that it's repeatable ordering, meaning if I'm reading, if I'm getting event B and A in that order for a read operation for one stream, one entity, one aggregate, and then I'm reading all the events in my from the storage, I will need to see first B, then A. There might be events before, after, in between, but that order needs to be repeatable because it makes it easier to build system, and it's actually fundamental. It's a fundamental property of distributed systems. When you look at the papers doing distributed system, consensus algorithm, they all are relying on something that is in order, even in as a simplifying factor to enable building something more complex on top of it. So that total ordering is or that repeatable ordering, I prefer to call it like that, is an important property, I think, of the storage that helps build application in a more simple.
Yeah.
And the reason I'm calling that repeatable ordering is one of the, let's say, discussion points we regularly have with people in the community and so on, is you don't need global ordering when reading entities. And it's like, because, and it's, let's say, a philosophical maybe point of view, I don't know, is that, you know, that order between, let's say I have order 1 and order 2, two entities, their own timeline. And they don't actually, on business-wise, they have nothing in common. So why do you want to put that in a total order? There is no relationship between them. But that's not the point. The point is from a consumption point of view. It simplifies consumption and makes consumption repeatable as well.
Yes, I mean, so firstly, there's the notion of the kind of mathematical notion of an ordered sequence. So that's defined quite precisely. And actually, Whitehead in his event-oriented philosophy defines this quite carefully with something called a Degen cut. So it's considered in terms of set theory. So if you think about a set of events, then you can cut them so that one set, you know, includes one thing and then another set, and then if you did another cut, then it would, you know, the intersection or the union. It's defined very precisely without integers, but it's more easy to understand it if you think about it as an integer sequence.
Yeah.
An integer sequence is just an example of such an order. But this notion of a serial ordering is quite fundamentally important. But then there's two kinds: there's the gapless sequence and the sequence with gaps in. And for the aggregate sequences, it's important that they're gapless. So you can count along them and make sure that the next event that you're going to be using to evolve the state of an aggregate is the next one that applies. You haven't missed one. But that turns out to be too onerous a requirement to make the total ordering. You can do it, but it's a little bit onerous and a little bit unnecessary too. The important thing when you're doing the total ordering is to make sure that the commit order is the same as the insert order, in that you don't insert something into the sequence that is positioned earlier than things which have been inserted earlier, so that you don't later insert things that come before the things that are already there, because consumers are going to be progressing along that sequence. And when they get to, one particular point, they're not going to be doing backtracking, because there's no way of doing that efficiently, how far back you go. And they're going to continue. So if something happens to fill in a gap later, then you'll miss it, and you don't want to miss it. So the notion of, I mean, first thing we should say is that the notion of having the bounded context control this goes back about 10 years too. So Vaughan Vernon put this in his Implementing Domain-Driven Design book, and described it as the bounded context controlling messaging, because otherwise the option, it's discussed by other people too, but the options are that you update your database and then send a message, or you send a message and then update the database, or somehow the database implements a messaging protocol, or somehow the things that you're recording are themselves the messages. And with event sourcing, if you're recording the events, they're not going to change. They can function as messages for downstream components to consume. But if you you need to record them in sort of sequences which correspond to the aggregate, so you can get the aggregate events and reconstruct an aggregate efficiently. But if you also record them in another sequence which provides them with the total order, then you can use those events to propagate the state of the application, which you only need to do if you're making a distributed system. But everybody's making a distributed system these days, because at least you need to back it up. At least you'll need, I mean, especially if it's event sourcing, you'll want some other views on the thing, because you can't query your events in the same way as you can query like a traditional CRUD model.
There's also the aspect, not even talking distributed system, but it is, if you look at it from a certain level, is at some point you will need analytics. Analytics needs also or build up read model for analytic consumption, and you need repeatability there as well. And it begins to be a distributed system if you look at it from a certain angle, at least.
Yeah.
And the thing being with analytics, they have aggregated functions which you aggregate data there across entity type, across boundaries, and across a whole bunch of sequences. And some of those aggregation function, well, if you do operation A, then operation B, it will result in another result as operation B and A. So again, if you don't have the capability of consuming in repeatable fashion, you will get into unwanted behavior.
Well, yeah, I mean, it just makes everything simple if you can just have exactly once semantics and have a totally deterministic event processing thing. I mean, it's actually quite once you identify the couple of ingredients you need to do that, then, which is basically counting in atomic transactions. As long as you can count and have atomic transactions, you can, quite in a relatively straightforward way, have totally deterministic systems. I mean, there might be some limitation, and if you need to degrade away from that for some reasons, then there might be, there might be some reasons. You might have good reasons to do that, but you can do that by degrading away from something which is totally deterministic, rather than trying to kind of climb up to from an indeterministic situation, throwing more and more reordering or deduplication and idempotent operations to try to make it reliable when you don't really know that what you need is to count along a sequence and to record things atomically, the position in that sequence along with the new state that follows from processing that event on the downstream side, and on the upstream side to commit the events together with something that's indicating the order that they're in altogether.
Yeah, from a, let's say, events perspective, from your own, you have your library, which has been, you've built it over the years, and you recently built it that client library for talking to EventStore directly, and some adapter in between for your library. But what you just all said, I guess those are things you expect on the library to make it, simpler to work with and more repeatable and understandable. The question is, do you think that what you've seen from the API level and the type of behavior you see on the EventStore client, it complies?
Oh yes, it's a great match. I mean, and it's no coincidence either, really, because there's some inescapable logic which you need to be able to record events atomically from an aggregate. There might be more than one event which results in a domain model from a user command, but you need to record all of the results of handling a request, an external request, atomically. They all need to be recorded together so that either it's happened or it hasn't happened. It can't half have happened. You don't want half of the. I mean, that's the thing. That's the thing that Eric Evans introduced, really, this notion of. I mean, we already had this notion of a unit of work, but the notion of a consistency boundary in domain-driven design is explained or defined, perhaps. Is characterized by the use of an atomic database transaction to make sure that all of the consequences of doing something to the graph of entities and value objects in an aggregate is recorded, or none of it is recorded. And then there's something else that happens. So already in Eric Evans's original book, you've got this sequence of things happening. You've got a serial ordered set of decisions that take it from one particular desirable state to another desirable state, which involves the fact, which involves many factors. So that's the first operation on the client, and the thing that EventStore supports is that you can atomically write with an expected position, so that you can make a gapless sequence, so that you can't overwrite the previous record, and you can't record number 5 when you haven't got a number 4. Those are important
when you already have one. Or record number 4 when you already have a 4 in.
Yeah, you can't record a number 4 if you already have a 4, and you can't record a number 5 unless you do have a number 4.
Yeah.
So what you're going to do is to record something that is a gapless, that's ordered with a gapless sequence of integers. So the events then occupy positions. Those positions occupied uniquely, and those positions are identified by integers, and those integers form a gapless sequence. And it happens to be 0 based in EventStore, but there's a detail.
Knowledge lacking. Does Python begin with 1?
Oh, well, yeah. When you index an array, you say 0. The first in Python is 0, but is it the 0th or the first? I noticed in the document you sent me today that you were describing the first event.
Yeah. A zero, yes.
is at position 0. So
Yes.
if the first one, maybe it should be number 1. Or, I mean, that's an age-old debate that we don't need to
Yeah.
have. But it just you just need to be clear what you're dealing with. Are you dealing with
Yeah.
zero-based
I do agree with
indexing
that.
or one-based? I mean, my library started off with. I mean, I chatted with Eric Evans about this actually, and he was like, "Yeah, 1's better than 0." So my aggregates start with their version 1 is 1. So when it comes to putting them in Event Store, we have to just start them at 0. It's a
Find it one.
configurable thing. You can say what the first version number of your aggregate is, but it happens to be by default 1 in my library. And also in Postgres, for example, when you have a database sequence, that's the way in which it's common to use a database sequence to issue the overall total sequencing numbers, which I call notification IDs in my scheme, but different people use different names for that. Those sequences by default start from 1, 2. So yeah, so that helps because if you want to kind of select, if you want to catch up, if you're a downstream component, you're wanting to catch up, then the logic of asking for things after a particular position, which is the position that you've so you're processing 1, 2, 3, 4. You record 4 as the thing that you've processed. So then you'll ask for things from 4. So you'll get 5, 6, 7, 8. But at the beginning, if you ask for things from 0, then you get 1, 2, 3, 4, 5. Otherwise, you'd have to ask for things from
you have to
1.
ask explicitly, give me from,
Yeah. So if you default to like 0, then if you go greater than 0, you get 1, which is the first one in the. So it kind of work, but I mean, it's a very small detail. It's possible to make it work well both ways. Anyway, so pending is the first one, and then obviously selecting. You want to get the ones for if you have an aggregate ID and you want to get the events, you want to get your aggregate, then you need to get the events for the aggregates. You need to select. So your database has to be able to give you those efficiently out of the whole volume of data from the database to get the particular small number of events, however long ago they were recorded, is an important operation to have. And then propagating the state of the collection, the whole application or collection or domain model or collection of aggregates or whatever you want to call it, the bounded context, involves then propagate. So I call that select notifications, but it's in EventStoreDB, it's read all. So EventStoreDB has read stream, read all, and no. So we've got append events, read stream. Was it append to stream? I can't remember now.
Oh, it may depend on in library, but it's basically append, read, and subscribe.
And then subscribe, yeah. So that's something nice that EventStoreDB does, which you can't. Which, for example, Postgres, you can't just subscribe. You can't just call a method on Postgres to subscribe from a particular position. You have to select from a particular position, and if you want to be notified, then you have to do a listen notify thing in Postgres. So that it turns out that works very, very well. You can just when you write events, you can send a notify to a channel, and then you can listen to that channel, and then you get prompted to pull, and then you can pull. You can also do this on the kind of application level too, so that it depends on the situation, how you want to configure these things. But for example, if you weren't say like SQLite, for example, you can't do them kind of multi-process listen notify thing. It's a particular Postgres feature. So one thing you can do is and also if you're using like doing development with an in-memory database that's just the objects just shoved into memory, so you can just do it really fast, then it can be useful to sort of prompt to pull from the application itself. So you can then subscribe to the you can follow or listen to the application itself, and the application can tell you, because then you can kind of abstract away from the database. So the application could get notifications from the database, or it could, but the notion of subscribing rather than having to pull, because if you have to pull, then you need to be prompted to pull, unless you're just going to be polling. But the notion of pulling or subscribing and following like that, rather than pushing, is rather than pushing events to a messaging infrastructure, message broker, if you can pull when you need to. I mean, the subscription in EventStoreDB is kind of a bit like pulling, really, in that you ask to be pulled and then it streams them out. And the difference between subscribing and reading is that it just keeps the connection open, the read connection open, so that when new things are recorded, you also get those. But it's like a read that doesn't actually end, it blocks and then continues to give you results when new things are recorded. But that's a really nice feature that works very well. But it is something you can implement in other databases, but it's certainly a nice feature.
Yeah. Plus the fact that if you look at it from EventStore perspective, you have different. You can subscribe to almost any sequence that you define, and you can subscribe to the everything. You can subscribe to specific type. You can subscribe to specific event. You can subscribe to specific things. There are ways to create your own sequence as well. If you use the projection engine, so that's kind of what I like, is that you're not limited to everything. You can choose, and where it makes sense, evolve to make it more, again, from let's say, oh, I want everything, then you notice, oh, this is putting a bit too much burden on the application side, because you need to drop things that you're not interested in. Then you can decide, oh, I'm only listening to, actually I only need that type of event, so I'm only going to subscribe to that type of event. So this type of feature that is in there as well, which do not necessarily, that's kind of an interesting one. Coming back to the framework library thing, that's not something that you would have, let's say, in your application, in the little framework you have for your application, but that gives you an escape route for when you need it. And then build something out of it, and you know how to build it because you have a sample over there. It's just that specific parameter, that specific subscription is slightly different than the rest.
Indeed, it's important to not have people working inside a box, but to I mean, from the kind of frameworking or library thing, for it to be well patterned, it needs to be at its core a cohesive mechanism, which really pertains to the inescapable logic of doing event sourcing, which is appending events from let's say, if we're doing event sourced aggregates, just to make it simple, appending events for an aggregate sequence, getting the events for an aggregate sequence, and then getting all of the events in the total order, and then doing things additional to that, obviously, is something that you can play around with. So, for example, one thing you can do is one thing that isn't illegal or against international law. It's not a war crime to record events for more than one aggregate in an atomic transaction. For example, I mean, it's not strongly encouraged by, and strongly discouraged indeed by, a respectable number of people. But it's certainly something that's technically possible. Another thing you can do, I mean, there's lots of things that you can do. So there's lots of things you can work out from there, but then you're adding to the basic core of what it is to have an event sourced domain model,
Yeah.
um,
Yeah. I think,
which is the core of event sourcing, isn't it?
yeah, that may be the topic of another discussion, I'm going to call them streams instead of aggregate because I'm on the database side of things, so I'm the database here. But multi-append stream, no, appending event to multiple stream at once is not something that Event Store does. But I do see in some cases having that would be a simplifying factor for building certain type of applications or certain use cases, making the code simpler.
Yeah, I mean, I have found it useful in certain situations to do that. And certain clients, I mean, I have clients as well who don't do Python, and there's a certain quality you get from processing. For example, you can imagine having a policy, an event processing policy, which is processing asynchronously the events of one domain model into another domain model. You can imagine processing those events back into the same domain model. So if something happens and there's consequences of that,
Oh
you
yeah.
then follow and process them and fold them back into the same domain model and further evolve the same domain model as a consequence of something happening in the domain model. So you can imagine that happening asynchronously after the fact. But then it may be that, for example, if you know if the model pertains to, for example, somebody achieving somebody accomplishing something, and they expect to be rewarded for that. If the rewarding is a consequence of the accomplishment, but the rewarding is allocated asynchronously, it may be the case that they can see that they accomplished something, but they didn't get their reward. And yeah, and technically, it may also be the case that the overhead of pulling events and processing them and making sure that the processing, the recording of the downstream processing along with the track, maybe the overhead of that is actually more altogether than it would be just to simply process the event as it's been generated before it's been recorded in a way that generates further events as if it's like an extension to the command.
Yep.
If you're going to allow commands to have more than one, commands to lead to more than one event, then it may be the case that you could have an event processing policy simply like a plug-in extension to a command. And then you process the first event, the original event, you end up with more events, and then you record those atomically. Yep. Maybe that just reduces overhead on the system, so you end up with greater throughput, even though the latency of the initial request is a fraction more than it would be if the thing had returned. It's like the overhead, which is like a lot compared to like recording one event, which is something, small. So it's going to be like a big thing plus a small thing compared to a big thing plus two small things. So it's going to be like slightly slower, but then you avoid all the overhead of the subsequent processing, and you avoid all the cost of like people raising issues when they did what you asked them to do, but they weren't rewarded for it. And like, where's my thing that I should get when I didn't get it, but I did? You can sit, and then it turns up. But I mean, it might be instantaneous, almost instantaneously. But let's say there's some problem with the event processing, and it's just stalled, or it's broken, or it's just not running, and actually that delay is quite long. You could have a call center full of annoyed people phoning up saying, "Where's my stuff that I should have got?" So having the consequences atomic in some cases might be useful, and that might be that, say, their boss gets something. So you have two different aggregates. It might be all the same one, so it might go across different. I mean, it's just a possibility. There's nothing in modern process philosophy or really in the statute books of England and Wales that means you go to jail if you do this.
Oh,
But but obviously it does involve some. It's adding a certain constraint which might compromise throughput if or some ways of arranging aggregates. For example, if your aggregates are all organized in actors individually, and commands are directed to each aggregate separately, and you can't really see how to kind of do it like that. There's all sorts of, I mean, but obviously it's
that's an interesting discussion, because I think side note a bit here. One thing you kind of describe trade-offs. Oh, I can have two design. I could have, or two implementation, let's say, of the system. One where you have those accomplishments coming in and then reactively give the reward, or I could do, have one processing and have the accomplishment and the computing of the reward stored atomically. Could be one stream, could be multiple stream. That is another thing. But the trade-off is, and that's where I find it interesting, is, oh, I might do in one because it augments my throughput. So there's some requirement somewhere which drives that design decision, and which also, those are interesting for me. That's where I want to get, because this kind of discussion shows a sign of maturity. Oh, we're building bigger system, we're building more complex system, and there's more needs that need, or more capabilities that are needed from the storage point of view, and having the right trade-offs. Oh, we need that because that's an actual need of the business somewhere, driving back to, oh, and we need that as a functionality capability of the storage and the application. It's kind of nice. It kind of showed that there's some kind of evolution over the last 12 years. There's some people that says that event sourcing is older than that. It's 2 or 6,000 years old. Okay.
Oh, well, that's what Whitehead was saying.
It's not just,
it's not just 6,000 years from accounting. It goes back to the beginning of the universe. I mean, the universe is one big event that hasn't quite finished happening.
Yes.
I mean, the whole thing about the universe is it's characterized by it's a process in a state of incompletion. But it's an ongoing thing. But the individual things that happen, once they've happened, they're then forever after things that have happened. They will never not they will never unhappen. They're immortal.
Yeah.
In their having happened. Their having happened is an immortal thing that never dies.
Yeah.
So they always. So that's like a general. I mean, that's never not true. Like, it's always true. But the things which happen are then forever after things that have happened. Like, the world is built up in this way.
Yep.
So, and the things that happen, and the way it's event sourced, so that's the way it's event oriented. But the way in which the process of becoming, which leads to new facts, or event sourced, is because they initially start with a set of what Whitehead calls feelings, abstracting, like you can abstract from visual light to light across the full electromagnetic spectrum, the things that the speed of light pertains to. You can abstract the feelings that we have as human beings to a broader notion, which is a kind of grasping of facts in the past. So what an event, on an occasion, what happens is that, firstly, the things from the past are grasped, and then they're creatively grown together into a unity, which the decision is a unity. So you can see that happening in a domain model, or in the processing of an event, or the record. There's a bunch of facts which are brought together into a unity, which is a decision. And that's essentially what an atomic database transaction is doing. A domain event is the bringing together of the facts of the code that the function is constituted of, the arguments that constitute the parameters of the command, and then the current state within which that command is being executed, which is the rest of the domain model. And those facts are brought together into a decision, which is a new event, which then is recorded as one amongst many, which then falls into the past as the collection of facts within which subsequent events. So you can see it very clearly, but you can also understand that that's how everything has always worked. And it couldn't have been any different. I mean, in some ways it couldn't. It doesn't matter if it could have been any different. The fact is that everything works like that, and that we are examples of that, and that software is an example of that, and with that we can have a common foundation for understanding what it is to be a person and what it is to be a software system. So that then we've got a common way of understanding everything. That's the wonderful thing about actually understanding. That's the wonderful thing about this. Finally, you're breaking out from the old mistakes, and which actually are mistakes. It's not just you being stupid. They're mistaken things that isn't understandable, that doesn't work. Ideas which were put into the fundamental ideas of how to do software in the 80s and 90s, and tricks were missed. There was a different game to play. So we're really correcting the history of software analysis and design, as well as working with sort of misunderstanding of what people are, that we're doing software. When we develop software, we do it with people, and also we do it for people. So we need to be able to grasp. I mean, when we're doing that, we're doing that in occasions of development, and those occasions start with grasping the facts from the past and growing them creatively together into new decisions with other people, and they're having their own feelings too, as well as you having your feelings. So you need to grasp how you're feeling within all of this, and also grasp that other people are having their feelings, and doing that is, the name for that is simply empathy. And so if you're not doing that, you're not being empathetic. But you can't just be empathetic. Oh, I wonder how they're feeling. It's the important thing is to connect and bring these feelings together into decisions which bring satisfaction in the technical design, as well as in the relations you're having with yourself and other people. Otherwise, the whole thing just can't proceed, because it cannot proceed in any other way, and doesn't. So I think it's just interesting to realize that, and to put the doing event sourcing in that context, and to understand one's learning about it is also a sequence of occasions of experience, and that having done this for a while, then we can help bring other people across that bridge, or through that passage, or whatever, along that path, by understanding that they will be having feelings, and that we need to help condition those feelings to lead to them having a greater depth of satisfaction in their work, by finally being able to bring together all the different things into some kind of coherent, satisfying unity with which they can make reliable software systems that people can enjoy using.
That's a good conclusion, man, because we begin with you telling how unsatisfying back then you were with having to go back to problem, and this is back, and that was for yourself, and then back to let's do the same for everybody. And
well, thank you for saying that.
That's we
I mean,
circle there, man.
That's very true. I hadn't quite noticed that, but
Okay, so that's a super cool conclusion. I think thank you for your time, John. That was.
Oh no, thank you for your time, Yves. It's good to see you again.
Yeah, all right. Cheers.